see one more problem from the superposition theorem is given here. So this is also a previous competitive exam question. Now in this network two independent sources are there, one is voltage source and another is current source, and one dependent source. So already explained, this rhombus symbol explains the dependent source. Now here one rhombus symbol is there, so this acts as a one dependent source, voltage dependent. There is a voltage source, voltage dependent, and one voltage independent source, another is current independent sources are there. So according to the superposition theorem, at a time only one source is activated. So initially I am applying here voltage source here. Voltage source is activated, current source acts as a open circuit because internal resistance of the current source is infinity. Now I am drawing the circuit. So resistor is as it is and voltage source is connected. Here dependent source. Then this current source acts as open circuit here. This acts as a open circuit. Then the voltage across these two terminals. According to the given problem, voltage across these two terminals is VAB. VAB. This value is 3 VAB. So this dependent source is completely depends on the voltage across these 2 points. Voltage across these 2 points. Now this, if it is opened here, this current source acts as open circuit. If these 2 terminals are open circuited, the current through the circuit becomes here 0. The current through the circuit is 0 because in open circuit current should be 0. So here resistance is infinity, resistance is there. So the current through the circuit is 0, but it has some voltage. The voltage difference between these 2 points is VAB. Now the complete analysis due to one source. That's why here I am assuming all these are VAB dash. VAB dash. So this resistance value is here 4 ohms is there. Now the current through the circuit is 0 amps here. Voltage across this becomes here 0 volts because voltage across resistor is I into R. I into R. The current through the circuit is 0. Then the voltage across this 4 ohms resistor is 0. But internally some voltage sources are there. Then I am applying here KVL analysis, Kirchhoff voltage law. So from that KVL analysis, from here onwards I am writing here. So this voltage is 3 VAB and plus VAB dash. So because I assumed with VAB dash. So here plus VAB dash and here voltage across this one. Voltage across this source is approximately 10 volts is there here. So minus 10 volts because enters with a negative terminal representation. So minus 10 volts and voltage across 4 ohms resistor, that is 0. So plus 0 is equal to 0. So apply just KVL, Kirchhoff voltage law. In any loop, algebraic summation of all voltage should be 0. So I am assuming this is one loop here because voltage across these 2 points is given, that is VAB dash. So according to that analysis, in this loop total voltage is equal to 0. Algebraic summation of total voltage is 0. Then simplification of this. So simplification, after simplification becomes here VAB dash is equal to 3 plus 1 4, 10 by 4. So 10 by 4 approximate value is 2.5 volts. So finally we got voltage across A and B terminals, that is VAB. That VAB dash is 2.5 volts due to one source, one voltage source. And superposition theorem explains at a time we have to apply only one source. So one source is applied. Similarly we have to discuss with another source. Another source is here, current source is there. So now I am taking second condition, current source is applied now. The current source value is 2 amperes. And voltage across these 2 points is VAB double dash I am assuming now because this response is due to second source. Now current source, this source is as this, it is as this is there, plus minus this value is 3 VAB and here one resistor is connected and one voltage source is there. So this voltage source value is 10 volts. And resistance value is here 4 ohms. 4 ohms. So now current source is connected, another source is eliminated. So voltage source is short circuited. So this is acts as short circuit. So there is no use of this one. Because from the superposition theorem analysis, at a time only one source is activated. So one source is activated here. This source is eliminated. This source is voltage source. So voltage source is short circuited. So now short circuited here. So voltage across these 2 points is VAB double dash. If it is VAB double dash, this also becomes VAB double dash. So now I am assuming this nodal voltage is VAB double dash. VAB double dash. Then I am applying here nodal analysis. Nodal analysis at this point. Totally 3 branches are there. One branch is this branch, and second branch, and this is third branch. But third branch is open circuited. In open circuited current is 0. So the current through this is 0 amps here. So we have to write only these two branch nodal equations. So this branch nodal equation is here. Current is incoming current. So minus 2. And again this branch. This branch voltage equation is VAB double dash, and here this is directly connected to ground. So VAB double dash, and this voltage is connected with minus here, plus VAB double dash plus 3 VAB double dash by resistance of this path here. Resistance is here 4 ohms is equal to 0. See, applied here nodal analysis at this point. At this point, this branch current is 2 amperes, incoming current, so minus 2 amperes, and this branch current is total voltage by resistance. Total voltage is VAB double dash, here minus symbol is there, that's why I wrote there, plus 3 VAB by 4. Then simplify this here. So after simplification it becomes here minus 8 plus here 4 VAB dash double dash is equal to 0. Then VAB double dash is equal to 8 by 4. This becomes now 2 volts. So here finally we got one response is 2.5 volts, another response is 2 volts. These two are individual responses. Then superposition theorem explains total response is equal to sum of individual responses. One is VAB dash plus VAB double dash. Sum of individual responses, now this becomes 2.5 plus this becomes 2. Then finally which gives the 4.5 volts. So here I applied superposition theorem. From this superposition theorem finally we got here 4.5 volts. So similarly we can apply here nodal analysis also. Similarly we can apply nodal analysis method. So according to the nodal analysis here we have to assume here nodal equation, find out the principal nodes. So just I am applying nodal analysis here. According to the given problem here VAB and 3 branches are there, this branch current is 0. Just directly I am applying minus 2 plus this current is incoming current, and this branch plus VAB minus symbol is there, so plus 3 VAB and 10 volts minus 10 volts by 4 total voltage by resistance. In this here VAB voltage are 3 VAB and 10 volts, 3 voltage sources are there. Then we have to write algebraic summation of all the voltage sources. So from that I wrote here VAB plus 3 VAB minus 10 by 4 is equal to 0. So then simplify this here, minus 8, here 4 into 8, 3 VAB, 4 VAB, it becomes here 4 VAB minus 10 is equal to 0. So minus 10 and minus 8, 18. So this becomes 18 by, here 4 VAB is there, VAB by 4. So 18 by 4 is 4 6 is 16 minus 5. So finally answer is 4.5 volts. There also 4.5 volts. See, if the question is find VAB, directly apply nodal analysis, then find out this. Here I am explaining this problem using superposition theorem. So how to apply the superposition theorem for the given network, that part I explained here. So from the superposition theorem, from the Thevenin's theorem, Norton's theorem, or mesh analysis, node analysis, finally the answer should be same. There is no changes in the response. Only the procedure is changes here. So here just I am explaining how to apply the superposition theorem, what is the importance of the superposition theorem. So that analysis purpose, here I explained here this complete problem with using superposition theorem, and this is using nodal analysis. If this question is a competitive exam question, multiple choice question, directly apply this analysis. Because we want here only output VAB voltage, that's it. So using any theorem or any method, so it takes only 2 or 3 steps, directly apply this technique and solve this. And if it is a conventional paper questions, academic purpose, just you have to apply, find VAB using superposition theorem means at a time we have to apply only one source. So like this, apply one source, then find out the individual response, apply second source, find out the individual response, then the total response is sum of individual responses. Previously I explained few questions. Those questions for solving of those questions purpose compulsory superposition theorem is required. Like two voltage sources are connected, network elements are not given, then there we have to apply compulsory superposition theorem. But few application purpose nodal is applicable and superposition theorem is also applicable. Depends on the question, depends on the exam. So you have to apply any one technique here. So just here I am applying, I am explaining here how to apply superposition theorem for different networks. Here I explained for dependent sources, how to apply the superposition theorem. So according to superposition theorem, only independent sources are eliminated, dependent sources as it is, means there is no changes in the dependent sources. So like this we have to apply here. And number of individual responses equal to number of independent sources. Number of individual responses equal to number of independent sources. In these two independent sources are there, it requires two individual responses. So don't consider this one. This is a dependent source. So please note on the solutions of a given problem.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SAIMEDHA.in app. If you open the app guys, you are going to see there. Let's talk about the store now. In some other branch, let's open a EEE branch guys. In the EEE branch you can see the content. In the content engineering, in the engineering we have electrical circuit, 75 videos there. In that mesh and nodal analysis, if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3, questions with solution, previous ecet questions with solutions, and at last we have what mesh and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys, based upon the topic marks. It is going to be there in the not only in ecet but also in the government jobs and PSUs. And at last you have there an online test examination also, in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ecet examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys, for EC, EEE and civil, this SSC JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board Junior Engineer and as well as ISRO guys. If you people are interested to watch all the full length videos in the SAIMEDHA.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486925998. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material, and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If not, if you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.